Hello and welcome to the session on mechatronics. Today's topic is programmable logic controller. Okay, myself, Professor V. Khond from KKW College of Engineering, Nasi. So the picture shown onto the slide is a Siemens logo kind of PLC, which is a basic kind of PLC. Okay, so let's start with the introduction. So PLC, it is a specialized digital controller that can control various kind of machines and the processes. So the processes may be a kind of chemical kind of processes, it may be a flow control process, it may be a composition control process. Okay, so it may be a industrial processes. So various kinds of machines, various kinds of processes, it can be controlled. So basically the PLC implements discrete kind of control in a mechatronics session. So we can have the two kinds of control. One is a continuous kind of control, another one is the discrete kind of control. So wherever the if you want to control the discrete kind of task, so we are implementing the PLCs. So we are using the PLCs over there for discrete kind of task. Now the next thing is to control the event driven sequential task. Now there are two kinds of tasks. One may be a time driven, another may be the event driven. So let us say a washing machine. So it is basically it is dependent upon the time. So for a set timing that washing machine works. Similarly for the event driven, let us say if you want to start the motor, after that if you want to start the wall, if you after then if you want to start the lamp. So it is a event driven. So one event get completed, then another event get started. So it may be a event driven kind of task. Okay, now the PLCs is very effective in such kind of task, that is event driven sequential task. Okay, now considering the PLC, basically it is a controller. So when we are talking about a controller, it receives the input from the sensors in the digital form. Okay, and it will give the output to the actuators in the digital form. Basically PLC, it is a digital device, okay, digital kind of controller. So it receives the input from the sensor and it will give the output to the actuators in the digital form, or we can say it is in the binary form. Okay, now it is a PLC architecture. Okay, so the input sensing devices on the left hand side and the output load devices on the right hand side. So input sensing, that is we can say we are talking about the sensors, and the output load devices we are talking about the actuators. So input sensing devices may be sensors, there may be a number of sensors. So the symbols shown into the left hand side, so it may be a kind of push button. Okay, so it may be a kind of temperature control, temperature sensor, it may be a level sensor, or it may be a kind of switch. Okay, and the input is being given to the input module of the PLC controller. Okay, input module then communicate with the main part of the, that is it is being showing in with the yellow part, that is CPU, memory. I mean the memory, it may be a program, it may be a data. Okay, after this it is being communicated with the output module. Okay, output module then communicate with the actuators. So it may be a motor, a lamp, or a solenoid. Okay, that kind of actuators. Okay, so whenever the central portion, that is the central processing unit, and the memory portion, so we require to have the power supply, we require to have the programming devices. Okay, we require to have the programming devices. Through the programming devices we are inputting the program to the memory of the PLC. Okay, now you can see the optical isolations in between input module and the CPU, and in between output module and the CPU. So there are two kinds of optical isolation. So the isolation, basically it is being separate out, isolation being the separate out from the digital device with the analog kind of inputs or analog kind of output. So basically it is a separation between analog and the digital one. Okay, as it is a digital kind of devices. Okay, this one we are talking about the running the program contact, normally open kind of contact. Okay, and the output may be a coil or the output. Okay, we can calling it as it is a AND gate. So we require two inputs. Okay, similarly in the OR situation, So input A, input B. If you give the input to A, the power will flow and the lamp will glow. It does not require the input to B. Okay. Now if you give input to B and if you are not giving the input to A, then also the lamp glow, because it is OR situation. Okay, so that kind of representation in the ladder diagram, it is being shown on the left hand side. Okay, so we are using two normally open kind of contacts. Okay, now the term latching. So these very important term. So whenever it is necessary to hold an output energized even when the input ceases, in that situation the latching works. So whenever the input gets stops, okay, and if you want to hold the particular output, then it will work. Okay, let us see how it will work. So this is the situation. So start button, start push button, stop push button. Okay, start button is nothing but a normally open kind of contact. Stop button is normally close kind of contact, and the control relay 1. On the control relay 1, so CR1 on the left, on the second rung, CR1. So whenever that CR1 energizes, CR1 in the contact, CR1 contact get started. Okay, so L1, L2, these are the power rails. Okay, power comes from L1. Okay, then input being given by the start button, by pushing the start button, so power flows, comes stop button, so it is normally close contact, goes to the CR1. CR1 will get energized. As soon as the CR1 energizes, here the contact of CR1, that is normally open contact, it will make the contact and it will give the output. Now we are having the two options, via start button and via CR1. Now now our question, even if when the input ceases means if you have the start button get off, yeah, okay, or if I removing the start button, then also the power will flow from CR1, stop and the CR1. Okay, now if you want the CR1 should get off, just push the stop button, so the contact breaks and CR1 stops. Okay, as soon as CR1 de-energizes, CR1 contact will get also de-energized. Okay, that is what the thing. Now representation in the ladder diagram. So this is the representation: input A, input B, output, and the output. Okay, now the next thing is the counter. So the counter being required for some control applications, say control applications that commonly use counters include the following. So there are three types of control application. Let us say count to a preset value and cause an event to get occur, that is up counter. Second situation is count an event to occur until the count reaches a preset value, that is the down counter. And the third one is up down counter. So three counters are there: count up, count down, and count up down. So in the count up, so you can see into the feature diagram, that is CTU being written over here, CU that is count up, R for the reset value, and PV for the preset value. Then CTD in the count down, CD count down, LD that means you have to you are having the load kind of thing, and a preset value. In the count up down, okay, so count down, count up, R that is reset, PV that is preset value. Okay, next is the timer. Timer are basically the devices that counts the increment of the time. Okay, so if you want the situation after some time my particular thing needs to be get started, so in that situation it counts the increment of time, and after that your output being run. Okay, now the types of timers. First timer is TON, that is timer on delay. Okay, on delay timer. So below figure, that is input being shown, input triggers, then after some time the output being done, because as the input triggers, it will start running, it will start the timer, and after some time you will be getting the output, that is timer on delay. Next one is the off delay timer, that is TOF, timer off delay. Okay, again the same thing in the counters, that is PV. Here we are writing PT, but the meaning is same, that is preset time. In the previous one it is preset value. Okay, in the timer of delay, okay, so the input being given. Okay, so after some time, so it will, you are getting the output, but after some time, okay, the timer started. Okay, as the input goes false, the timer started and you will not be getting the output. So that is what the off delay timer. Then the next one is third timer is retentive on delay, that is TONR. So as the name suggests, it is retentive, so it retains the value, it retains the previous value. So from that previous value it will run. Okay, so it will hold the time and it will run, so or it will accumulate the time and it will run. So that is retentive on delay time. Okay, so we stop over here. Okay, thank you.